I'll be discussing on the uh, on Zener application, which is the third part to your module 1. Contents discussed will be voltage regulation with variable input voltage, Zener regulation with variable load, Zener regulation from no load to full load, and Zener limitation. Zener regulation using variable input voltage. Here in the figure you can see that the DC voltage is varied and you will get the variation in the current, and accordingly we will try to measure how much is the change in the output voltage. So the maximum current that can be obtained by varying the input voltage is IZM, and the minimum current that can be measured is by using IZ. As the input voltage decreases, the relative input current decreases, the load voltage remains constant. We'll try to determine, this problem tells that determine the minimum and maximum input voltage that can be regulated by the Zener diode. So how will you solve this problem? Here you will have to vary the input voltage and try to measure the current in the resistance, that is 100 ohms. Based on that you will get the voltage regulation offered by the Zener diode. So input voltage is nothing but IZ into RZ plus whatever is the voltage measured across the Zener diode. So input minimum voltage is IZK into R plus V output. So it is 4.86 volts. So what will be the maximum Zener current? So power dissipated, maximum power dissipated upon the Zener voltage, which comes out to be 196 milliamperes. So at the maximum output current or the maximum Zener current, what will be the maximum output voltage? That is the Zener voltage that is given on the data sheet plus whatever was the variable voltage that has taken place or we have measured. So 1.5 volts plus the difference of the currents, that is between the maximum current allowed by the Zener diode and the knee current into the voltage offered by the Zener. So that comes out to be 6.13 volt. So V in max is equal to IZMR plus V output, which comes out to be 27.7 volts. This problem is carried out on multisim, and here you have to find out the requirement of the problem is like Zener is given to you, which is 1N477 NA, resistance is 100 ohms, and you have to find out how much is the regulated voltage that you can measure. So from the scope reading we can see that the output voltage that is measured is almost 12 volts. So that much is the output voltage regulation that is offered by the Zener voltage or the maximum voltage that is available across the Zener. So Zener voltage using variable load. So here is the situation when no load is applied. So we get an output voltage of almost 15.045 volts, and this duration that is measured is 98.336 milliseconds. When full load is connected, a load of 200 ohms you can see is connected in parallel with the Zener diode. Of course, the input voltages is that is firing the Zener diode is 24 volts, and input resistance is 100 ohms. So by applying a resistance of 200 ohms, what will be the voltage regulation that can be achieved? So definitely we can see from the oscilloscope screen that voltage has come down from 15 volts to 14.99 volts, and the time duration for which it is measured is 96.821 milliseconds, and which almost remains stable from 96 to 181 milliseconds. Now this is application of Zener as an limiter. What I am doing here is I am trying to find out the limitation of the Zener, right? And in this particular problem relation, I have considered the Zener as IN5270B. Input resistance is 1 kilo ohm, and try to find out how it is limiting the output voltage. It is cutting. You can see that the output voltage in the negative half cycle is limited. Okay, so in this way it is working as a limiter in the negative half cycle. Why? Because the Zener diode is conducting in the negative half cycle of the input signal. So input signal what I am applying is a AC signal. Next, when two Zeners are connected, one which is conducting in the positive half of the input signal and another is in the negative half of the input signal. So signal that I am considering here in this particular problem statement is the sinusoidal signal having a frequency of 100 hertz and amplitude of 20 volts peak to peak. So based on this, I am getting a cutoff signal which is limited in the positive half cycle as well as in the negative half cycle. Fine. We will get a continuous time signal having a voltage per division as 5 volts per division. Fine. So that completes the application of your Zener. Basics of Zener you have already seen in the previous discussion.